So students, in my last video, we have learned the phenomenon of photoelectric effect. Okay? What is meant by photoelectric effect? The phenomenon of ejection of electrons from certain metals, potassium, rubidium or cesium, when light of suitable frequency falls on it. This is called photoelectric effect, and the ejected electrons are called photoelectrons. And the very important observation of photoelectric effect is the kinetic energy of photoelectron is directly proportional to frequency of radiation. Okay. But all these observations could not be explained by electromagnetic wave theory of light given by Mr. Maxwell. In order to explain photoelectric effect, a famous scientist, Max Planck, put forward a new theory of light. It is called Planck's quantum theory of radiation. Okay students, today let us discuss the postulates of Planck's quantum theory of radiation. Okay, first postulate, please listen. Radiant energy is emitted by discontinuously in the form of small energy packets called quanta. Okay, for example, we know sun is the main source of radiant energy. Okay, sun emits this radiant energy in the form of small energy packets. Small energy packets. These energy packets emitted by by sun, okay, is called the packet is called quanta. Packets are called quanta. Okay, in the case of light, this energy packet, this quantum of radiation, are called photons. Okay. Then the next postulate, the amount of energy associated with each quanta, each packet of energy, the amount of energy associated with each packet of energy, each quanta, is directly proportional to frequency of radiation. Okay, that means when frequency of radiation increases, energy associated with the quantum also increases. Okay, that means E equal to a constant h into nu. H is a constant. H is a constant called Planck's constant. Planck's constant. The value of Planck's constant is 6.626 into 10 raised to minus 34 joules second. Yes, E equal to h nu. That is h equal to what? E by nu. The unit of energy is joule and frequency is a second inverse. Hertz or second inverse. 1 hertz is equal to 1 second inverse. That means the unit of Planck's constant is joule second. Yes, joule second. That means a quantum, energy packet or a photon possess h nu amount of energy. Okay, but that means h nu is the amount of energy associated with the quantum, with a packet of energy, with an energy packet, h nu. Yes. Then third postulate, the last postulate, the third postulate of Planck's quantum theory. Please listen. The total amount of energy emitted or absorbed by a body is an integral multiple of quantum. The total amount of energy emitted or absorbed by a body is an integral multiple of quantum. That means what? Integral multiple of quantum means what? We know a quantum, energy package possesses h nu amount of energy. Integral multiple means nh nu. Okay. Here n means what? N and the integers 1, 2, 3, etc. That means, suppose 10 joule is the amount of energy associated with the quantum. Suppose a source emits, okay, one packet of energy. The total amount of energy emitted is 10 joule. That is E equal to 1h nu. Suppose a source of energy, a source of radiant energy emits 2 packets of energy. The total amount of energy emitted by that body is 10 plus 10, 2 into 10, 20 joule, 2h nu. Then 3 packets of energy, 3h nu, 3 into 10 joule, 30 joule. Yes, like that. That is the third postulate of Planck's quantum theory. Yes. Next, I will explain the explanation of photoelectric effect by Planck's quantum theory of radiation. Suppose this is a light metal. This metal may be cesium, potassium, or rubidium. Yes, a light metal. This indicates the electron present in the surface of metal. Okay. Then suppose h nu is the, yes, we know h nu is the amount of energy possessed by that incident photon, okay, of light. That means photons, light having energy h nu strikes the metallic surface. Then some of its energy is used to eject electron from the metallic surface. Okay. Yes. The minimum amount of energy required to eject electron from the metallic surface is called the threshold energy. In my last video, yes, we have learned the concept of threshold frequency, nu zero. E is, according to Max Planck, E is directly proportional to nu. That is what? E0 is directly proportional to nu zero. Okay, threshold energy is directly proportional to threshold frequency, or the threshold energy of a metal is h nu zero. Threshold energy of a metal is zero. This threshold energy is also called binding energy or work function. Yes, then what is meant by threshold energy? It is the minimum amount of energy of light required to eject electron from the metallic surface. Yes. So here, yes, a photon having energy h nu. Yes, fall on the metallic surface. Some of its energy is utilized in the form of threshold energy, that is h nu 0. Threshold energy. The remaining energy is used in the form of kinetic energy, half mv squared. That means, suppose, yes, 60 joule is the amount of energy possessed by the incident photon. 10 joule is the threshold energy of that metal. Threshold energy of a particular metal is always constant. Okay, already we have learned threshold frequency is different for different metals. Okay, then the threshold energy is also different for different metals. That means a particular metal threshold energy is always constant. Threshold energy is always constant. Suppose here 10 joule is the threshold energy. Then out of 60 joule energy, 10 joule is utilized in the form of threshold energy. The remaining energy, 50 joule is used in the form of kinetic energy. Okay, that means here 60 joule equal to, okay, that means h nu 60 joule is equal to 10 joule. 10 joule is the threshold energy, h nu 0, plus 50 joule. 50 joule is the kinetic energy. Yes. Then, please listen. Then we can increase the frequency of incident light. When frequency increases, the energy associated with that photon also increases. When frequency increases, we know the energy associated with that photon also increases. Yes. Then the energy is increased. Suppose energy is increased to 80 joule. Out of 80 joule, 10 joule, 80 joule. Yes. 10 joule is used in the form of threshold energy. The remaining energy is 70 joule. 70 joule is used in the form of kinetic energy. That means 80 joule is equal to 10 joule plus 70 joule. Okay. Yes. Then we can say that when frequency of radiation increases, kinetic energy of photoelectron increases. Yes. The very important observation of photoelectric effect. Kinetic energy, when frequency of radiation increases, kinetic energy of photoelectron also increases. Yes, that means the observation of photoelectric effect, the phenomenon of photoelectric effect can be explained using quantum theory of radiation. Yes. Okay, then we can derive a very important equation here. What? H nu is equal to what? H nu is equal to h nu 0 plus Ke, kinetic energy. Yes. Okay. H nu, energy of striking photon, is equal to threshold energy of that metal plus kinetic energy of the ejected electrons. Yes, that is, therefore, kinetic energy of the ejected electrons is equal to h nu minus h nu 0. That is, kinetic energy is equal to h into nu minus nu 0. Nu minus nu 0. Yes, here nu is the frequency of incident photon and nu 0 is the threshold frequency of that metal. Okay, let us solve some important problems related to Planck's quantum theory of radiation. First problem, very simple problem. Please listen. Read the question carefully. Calculate the minimum amount of energy. Minimum amount of energy that the photons must possess to eject electron from cesium metal. Here you have to calculate the minimum amount of energy of the photons required to eject electron from the cesium metal surface. That energy is called the threshold energy. Our aim is to calculate threshold energy is 0. Yes. Here the threshold frequency of cesium metal is given. The threshold frequency nu 0 is 4.6 into 10 raised to 14 second inverse. Okay. That means what? E0 equal to h into nu 0. The value of h, Planck's constant, is 6.626 into 10 raised to minus 34 joule second into nu 0 is 4.6 into 10 raised to 14 second inverse. 6.626 into 4.6. The answer is about 13.4. You please check the answer, okay? Yes, then 10 raised to minus 34 into 10 raised to 14. Okay, 10 raised to minus 20. Second inverse cancels. The unit is joule. Okay, then yes, 30.49 into 10 raised to minus 20 joule of energy is required to eject electron from the cesium metal. Next problem. Calculate kinetic energy of ejected electrons when UV radiation of frequency 1.6 into 10 raised to 15 second inverse strikes the surface of potassium metal. Here the threshold frequency nu 0 of potassium metal is 5 into 10 raised to 14 second inverse. Okay. Then yes, we know kinetic energy of ejected electron is equal to h into nu minus nu 0. Here 5 into 10 raised to 14. 10 raised to 14 can be converted in the form of 10 raised to 50. 10 raised to 14 into 10 is 10 raised to 15. Then we can divide 5 by 10. 5 by 10 means 0.5 into 10 raised to 50. That means 5 into 10 raised to 14 is equal to 0.5 into 10 raised to 15. Okay? 0.5 into 10 raised to 15. Then h 6.626 into 10 raised to minus 34 joule second. Frequency of incident light is 1.6 into 10 raised to 15 second inverse. Okay, minus 0.5 into 10 raised to 15 second inverse. Second inverse. Okay. Then 10 raised to 15 also common. Then 6.626 into 10 raised to minus 34 joule second. 1.6 minus 0.5 into 10 raised to 15 second inverse. Second inverse cancels. Okay, 1.6 minus 0.5 is 1.1. That means 6.626 into 1.1 into 10 raised to minus 34 into 10 raised to 15. 10 raised to minus 20 joule. Okay. Okay, students, in my next video, I will discuss the next development leads to Bose atom model very important concept, atomic spectrum. Goodbye, study well.